In this lesson, we're going to take a look at friction. We know that friction is a force that opposes motion, and we remember that a force is a push or a pull that's caused by an agent. So friction, force that opposes motion. Or intended motion. Now that's a little bit different, and we'll talk about that in a minute, but I want to wrap our heads around what we just said. Friction is a force that opposes motion. A force is a push or a pull, and it has to be caused by an agent. So what's the agent that causes friction? Well, it depends on the situation. There are various types of friction, right? So types of friction include fluid friction. Okay. Fluid friction is exactly what it sounds like. This is a force that opposes motion when an object is moving through a fluid. Remember, a fluid is a gas or a liquid or anything that easily flows. So imagine I've got my little fishy here swimming through the water. Well, the water is made up of a whole bunch of molecules, and as the fish swims through those, he has to displace the molecules, and those molecules rub against the fish, and that causes some resistance, right? So there's this frictional force because it's moving through water. We get the same thing when we're moving through air. And it depends on speed and it depends on shape. If you've ever played the game where you put your hand out the window while you're driving on the car, there's not very much resistance there at low speeds. But when you speed up, you can feel that air is pushing harder and harder and harder. And you can turn your hand and change that force a little bit because you're changing the shape of the object as it moves through the fluid. So fluid friction, this opposes motion when an object moves through liquid or gas. Now, there's a couple other types of friction that I want to look at, and one of them is going to be static friction, which is that intended motion, and the other is kinetic friction. So kinetic friction, kinetic means moving or changing. So kinetic friction, this is also called sliding friction. This is the force that opposes motion when one surface slides across another surface. We have two objects in relative motion. So this opposes motion when one surface slides over another. Okay. So just like we had to have an agent that caused that fluid friction, it's the molecules of the fluid, we need an agent that causes this sliding friction. And that's because we have two surfaces in contact with each other. They're being pushed into each other. We generally think of sliding two things past each other, and so if I have a box being drug across the ground, the box is being pushed into the ground by gravity, and then the ground pushes back up on the box, and so there's this force between those two surfaces, and that's what actually causes this frictional force to exist. And so as I apply a force this way, I'm pulling it this direction, there has to be enough force here to balance this kinetic frictional force to keep it in motion, which is different than inertia, right? Because inertia doesn't want to stop things. Inertia wants things to keep doing what they're doing. So if I put this in motion, it will continue moving, but because if I don't continue to pull on it, the only force acting would be friction. That's going to slow it down and stop it. Now, if it's at rest and nothing's trying to make it move, then the only forces acting on it are the force from the ground and the force from gravity. I guess I should label those better than G. Those two forces will balance each other and this thing won't spontaneously start moving. But friction is not acting on it before something's trying to pull on it. Otherwise, there would be this unbalanced force and it would accelerate. But that leads me to this intended motion thing I said earlier. I said intended motion. Friction could oppose intended motion. If I look at this case, if I start to pull this way, that box is not going to begin to slide right away. Instead, these two surfaces are in contact, so as soon as I start pulling this way, that frictional force is going to be like, whoa, no, stop. Okay? And we're not quite moving yet. We're trying to make it move, but we're not moving yet. And so we get is static friction. And static means at rest or not moving. So this prevents an object from beginning to move. Okay? And it's Also, it rises because of the force between the object and the surface that it's resting on. So this prevents an object from beginning to move. It acts between two surfaces that are not sliding relative to each other. And so it must be overcome to put an object in motion. Now, what's cool about this static frictional force is it changes, right? Because if I pull just a little bit, static friction pulls back just a little bit. If I pull a little bit harder, static friction pulls back a little bit harder. If I pull a little bit harder, static friction might pull back a little bit harder. But there will be a breaking point. I pull a little bit harder and static friction can't pull any harder. We've exceeded the maximum static frictional limit, and so at that point my box begins to slide, right? So we were balanced up to here, and then I gave just a little bit more, and now I have a net force to the right. This thing can accelerate to the right. We overcame static friction. In the event that there was no friction, as soon as I apply any force that direction, the box starts to accelerate in that direction. With static friction, of course, I have to balance that frictional force.